Let us first learn what is a set. Now just observe the pictures which are shown on the slide. You will see there are some birds which are seen, some ornaments and some uh, household furniture. Now try to relate each of the picture and try to group them seeing their similarities. So here we have grouped three of the examples given, that is a chair, table and a bed. They fall under one common group, that is furniture. Okay, so here this group is nothing but our set given to us, and here furniture is nothing but the name of the set. And the example of the furniture is given here is nothing but the element of the sets. So here, as they have given us furniture as our first set, we will see what is given in the other pictures, other six pictures which are still remaining. Okay. Okay, now let us see how to identify a set. In the earlier slides, we have learned what is a set. Now, whenever they give you a statement and they ask you to identify whether it's a set or no, first you read the statement and try to understand it. Now, here I have given two examples. All good books in our school library. Second one, all interesting books in our school library. Now, here the adjectives which are used, good and interesting, will differ from person to person. Maybe one child is finding a particular book to be interesting, but the other child will not find it interesting. Correct? So whenever you have such kind of statements given where we don't have a well-defined set of objects, such statements do not form a set. So when they give you such kind of statement, you will straight away write it is not a set. Okay, but if I tell you uh, planets in our solar system, we know our planets, it's a fixed set, right? Or if I tell you uh, the colors in the rainbow, we know there are 7 colors, right, Vibgyor? So it is a fixed set. So now you know what how to identify a Now observe each of the statement given below and state whether it's a set or no. Now remember what I have explained you in the above examples, okay? So we start with the first one. So our first statement is first 10 counting numbers. We clearly know which are the first 10 counting numbers and therefore it is a set. Next one, all natural numbers. We know all the numbers that begin from 1. They form natural numbers. So 1, 2, 3, 4, 5 and it goes on. So it is a set. All beautiful flowers in the garden. Now here again we have an adjective used that is beautiful, and from person to person the meaning of beautiful may differ. For a person a flower may be beautiful, for the other person he may not find the same flower to be beautiful. Therefore it is not a set. Next one, all strong forts in Maharashtra. Again here we have an adjective use that is strong, and this is not a set. Next, all intelligent students in the class. Now again here from every person's point of view the intelligence will be different. So for me maybe so and so child is intelligent, but for the other teacher maybe some other child is intelligent. Okay, so here it is not a set. Okay students, so in the earlier slide we have learned to identify whether a given statement is a set or no. Now let us see few more terms involved in writing a set. Remember our first example which we had taken, furniture, in the earlier slides? Yes. So there in the set we had chair, table and bed. Okay. Now here, can you see the name of the set was written as furniture? But every time you can't have such big words given as the name of the set. So here we usually name a set using a capital alphabet. So instead of writing furniture, I can just write capital A, which is equal to chair, table, bed. So the name of the set can be given by any alphabet from A to Z, but it has to be written in capital. Okay. Next. Now whatever are the members of the group. Which are the members of the group over here? Chair, table and bed. Now these members are known as the elements of the group. Okay, so you will not say what are the different things in the group. You will use the word elements. These elements can either be any example of furniture or example of colors, planets, names of flowers, vowels, anything. Natural numbers, even numbers, odd numbers, squares, square roots. So it will differ from question to question, but they are always termed as elements. Okay. Now let us take another example of set B. So B is equal to bracket A, B, C, D, E. Now here capital B is the name of the set and the elements are small a, B, C, D, E. Okay. Now each element belongs to set B. Yes or no? The statement means that each element present in the set is belonging to set B. Correct? So if I want to write the same thing in the symbolic form, we have a symbol given for belongs to. Can you see that symbol over here? So if I want to write that small a is present in set B, I'll write A belongs to B. If I want to write small e is present in set B, I'll write E belongs to B. Okay. Now look at the last point. G is not present in our set. Can you see G anywhere in the set? No. Means it does not belong to our set B. Therefore, if I want to write the same thing in symbolic form, I will again use the same symbol of belongs to and I'll just strike it off with a line which indicates that it does not belong to set B. So if you just remember here, what are elements of the set? How do we name a set? That is by using capital alphabets. How do we represent the relation between the elements in the set? By using the belongs to and does not belong to sign. Okay. Let us observe some more examples of sets. Here capital N represents set of natural numbers. We all know natural numbers start from 1 and it goes on, and whenever you have a set which is not ending at a specific point or a limit, we always represent it by writing these 3 dots, only 3 dots. Okay, not more than that. So your natural numbers n is equal to bracket 1, 2, 3, comma, and 3 dots indicates that it is never ending, which we will learn further when we learn types of sets. What are they known as? Okay. Then capital W stands for whole numbers, a set of whole numbers. We all know that whole numbers start from 0. So here the elements are 0, 1, 2, 3, and again 3 dots. Next, capital I stands for integers. Okay, so here integers include positive integers, negative integers, as well as 0. So we know that negative integers also go on extending on the left side and positive integers go on extending on the right side of the number line. Therefore, here when I am writing a set of integers, you will see left hand side also I have 3 dots and right hand side also have 3 dots, because both sides the numbers can go on extending till infinity. Okay, so do not forget, whenever you write set of integers, 0 has to be there. Next, Q is the symbol used for set of rational numbers and R is a set of real numbers. Now let us learn what are the different methods of writing sets. First is listing method, or known as the roster method, and the next one is rule method or set builder method. We will see in detail how are these methods used to write a set in the following example. Now let us start with the first method, that is listing method or the roster method. Now here listing word itself suggests a list of some objects or list of some items. So here listing method is when they give you a statement and you are writing its elements in a bracket using commas. Look at the example given here. A set of odd numbers between 1 and 10. Now which are the odd numbers between 1 and 10? 3, 5, 7, 9. So this is the list of odd numbers which I have from 1 to 10. And therefore, when I write it in the roster method, it will be A is equal to, in curly brackets, 7, 3, 5, 9. Now again here the arrangement of the numbers, the placing is not important. I can start writing from 9, then 3, then 5, 7, or I can start writing with 5, 3. So I can interchange the placing of the numbers, that is not a problem. But the elements have to be same. Now one more thing in this method, I cannot repeat the same element twice. Look at the second example. If an element comes more than once, then it is customary to write the element only once. For example, in the word remember, we can see in this word there are many letters which are repeating, that is R, M, E. Okay, so now when I write down its elements, I am not going to write them again and again. So we write only one type of element once. So here my set will be A is equal to R, comma E, comma M, comma B. Now we see the second method of writing a set, that is rule method or set builder method. Now here also again the name of the method itself, set builder or rule method, means there are some criteria or some rules which we are going to follow while writing a set. Okay, so here we do not list the elements, but we write the general element using variable followed by a vertical line or a colon, and then we write the property of the variable. I'll make it simple for you. Look at the example given here. A is equal to x. Those two dots means such that. You can also write a straight line instead of a colon. So it can be a vertical line or a colon. So I'll read again. A is equal to x such that x belongs to n, comma 1, x is greater than 1 but less than 10. So exactly what is the meaning of this given set? It means that x is nothing but they have given this description of one element in the set. So x is one of the element in the set which belongs to n, means this set comprises of natural numbers. Now we know natural numbers are many starting from 1, but again they have made it very specific for us in the next part, stating that this element is greater than 1 but less than 10. So which are the natural numbers greater than 1 but less than 10? That is 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here this is the meaning of the given set, and therefore we read it as set A is a set of all x such that x is a natural number between 1 and 10. So if I have to write my answer to this in the list form, I will write A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9 and bracket close. Each element should be separated by a comma in between. Okay, so two methods are clear, listing method and the set builder method. Let us see some more examples of how to write a set in listing method form and also in set builder form. Look at the first example given here. A is equal to D, comma I, comma V, comma S, comma O, comma N. So here it is nothing but the word division. So how do I write it in the set builder form? A is equal to X such that X is a letter of the word division. Now here, whenever they give you any word like this, you always write in capitals. Okay? And here, when I say X such that X is a letter, I always write in a singular form. So I am writing about one element of the set. I will not write X are the letters of the word. No, it will be X is a letter of the word division. Always in a singular form. So we describe about one element in the set and which is same for all. So they are of same type. Okay. Next one. B bracket minus 3 and 3. Okay. So here y such that y is a number such that y square is equal to 9. So here we have found out some relation between minus 3 and 3. Okay, so both of them when we find square of it, we get 9 as the answer. Whether I find square of -3 or I find square of 3, I get my answer 9. So that's why they have written here y such that y is a number where y square is equal to 9. Now you might be thinking, why have I written y over here and in the above question x? Here you can assume any alphabet when you're writing in set builder form, but make sure it is written in small, not in capitals. Capitals are only used in the roster method or the listing method. Okay. Next question. C is equal to 5, 10, 15, 20, 25. Now here if you observe, this is nothing but our table of 5, right? So here when I write this in rule method, it will be Z such that Z is a multiple of 5, correct? And now here multiple of 5, if I only write till here and leave, it will be an incomplete statement because we know multiples of 5 can go on till infinity, correct? So here we will mention that only the multiples less than 30. After 25 next is 30, therefore we will write less than 30. So these examples are clear. Now I'll give you some more examples and you will have to get the answer to it. Okay. So this table has two columns, listing method and the rule method. There are some blank columns which you need to solve. Okay. First one is already solved for us. A is equal to 2, 4, 6, 8, 10, 12, 14. Now all of these are even natural numbers, but again they are only less than 15. We don't have numbers more than 15. So when I write in rule method, it is x such that x is an even natural number less than 15. Second one, we have to find in the listing method. They have already given us rule method. Rule method states that x such that x is a perfect square number between 1 to 20. Now what is the meaning of a perfect square? Perfect square is nothing but a square which is obtained by multiplying the number itself. So 1 into 1 gives me 1, 2 into 2 gives me 4, 3 into 3 gives me 9, and so I'll get my answer. So think over it and get the answer. Okay. Next one. We have C is equal to A, E, I, O, U. Now what are these alphabets? Correct. You have guessed it correct. So these are vowels. Now think how will you write this in the rule method or set builder form. Next. D is equal to Y such that Y is a color in the rainbow. Think which are the colors in the rainbow and what are the symbols for them and how will you write it in the listing form. Next one. P is equal to X such that X is an integer and that to minus X is greater than -3 and less than 3. So here my answer will be P is equal to, yes, correct. So it will be the integers which fall between -3 and 3. Now here you will not include -3 and 3 in your answer because that is the range given. So the integers between them will be my answer. Okay. Next one. M is equal to 1, 8, 27, 64, 125. Can you find some relation between each of the number given here or the element given here? Yes, they are nothing but cubes of the natural numbers. So here 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64 and 5 cube is 125. So accordingly you write your answer. So students, this is our practice time now. Let's see how well you have understood whatever I've taught till now. So practice set 1.1. First one, we have to write the given statements in the roster form. So here, first one, set of even numbers. So which are the even numbers? We start from 2, 4, 6, 8, 10, 12 and so on. So here we have our answer written in brackets with 2, 4, 6, 8, 10, and then as it is an infinite set, means it is not ending, you will write 3 dots and then close the bracket. Set of even prime numbers from 1 to 50. Think which are the prime numbers between 1 to 50. Correct. So we have only 2, which is a even prime number. So my answer is only element, that is 2. Next. Again here one more thing. They have not named the set. So it's up to you. You take any alphabet which you want, but make sure you always name it with a capital alphabet. Next one, set of negative integers. So again here you will write -1, -2, -3 and then 3 dots, which indicate that negative numbers can be written till infinity. Okay. Next, 7 basic sounds of sargam, that is sur. So here you will have to write down the name of the sargam. So we will write sa, re, ga, ma, pa, tha, ni in brackets. You will see that in the solution, okay? Next, write the following symbolic statements in words. You have to just write them in words, nothing else. No writing set or nothing. So 4/3 belongs to Q, means it is an element of set Q. Now -2 does not belong to M, means -2 is not an element of set M. P is equal to P such that P is an odd number. Correct? So you have to just convert this or translate it into word form. That's it. So just have a look at the solution, and whichever questions are not solved here, those you have to solve on your own. Okay? Let us move further with the exercise. We have question 3. Write any 2 sets by listing method and by rule method. So here you have to just take an example of your own and start writing. For your reference, I have solved using one example below. Now question 5, the last question of our exercise. Write the following sets using the rule method. First one, A is equal to 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Can you see something is common in all these numbers? Some pattern is being followed. Yes, you're correct. These are squares of the numbers. Now, what type of numbers are these? These numbers are nothing but natural numbers. Yes? So now when I start writing my answer, I will first start writing x such that x is equal to n square. So it is not directly equal to natural numbers. It is equal to natural numbers but in some pattern, that is in a square pattern. Then I'll write these belong to natural numbers, but to which natural numbers? The numbers which are less than 10. Next is B is equal to 6, 12, 18, 24, 30, 36, 42, 48. Yes, you're correct. These are multiples of 6. So here again we will write x such that x is equal to 6 multiplied by n, where n is nothing but natural numbers and these natural numbers are only less than 9. So this is how we write down our